Circular monoplastic packaging is a project funded by Innovation Fund Denmark Grand Solutions. We're 11 partners representing the entire food packaging value chain. The aim of the project is to develop a plastic film which is suitable for wrapping of food products such as cheese, bread and powders. We are working with the material PET. For this project we have 4 important challenges. We have to ensure food safety, we are looking into welding, we are dealing with barriers, and we have to of course make sure it is circular. So let's hear more about this.
Food safety is a major aspect to be addressed when developing new packaging materials. For this reason, Circular Monoplastic Packaging Project uses polyethylene terephthalate as a basic material for implementation of flexible circular packaging materials. And polyethylene terephthalate is known to be food contact approved. There is nothing new in it. What's new, according to recent regulations of the European Union, is that polyethylene terephthalate can be actually used for food packaging applications after recycling. And this exhibits a challenge by itself, because we need to keep polyethylene terephthalate as clean as possible after imparting necessary functionalities, so that we could use polyethylene terephthalate after recycling again and again in the food packaging applications.
Flexible packaging films comes in kilometer-long continuous lanes, and the food industry uses a packaging machine to wrap it around the food and then heat seal the edges of the package in order to protect the food inside. In order to be able to heat seal it, you actually apply a different kind of polymer on top of a PET film, take an example. This polymer, polyethylene, makes out 50% or even 75% of the total mass of the film. And this makes the recyclability, or it ruins the recyclability totally, because you cannot separate the two plastic types anymore. In the project, our solution is to print a sealing layer only where it's needed, so along the edges, and also to make it much thinner than the normal polyethylene layer. So now the foreign material, which is not PET, only makes up 5% of the total mass. And this makes it much more recyclable as PET.
Polyethylene terephthalate films are relatively good flexible barrier materials. However, the barrier performance is frequently not enough for some challenging food packaging applications. This is why the industry would typically use polyethylene terephthalate in combination with other flexible plastics, with other flexible polymers that would complement its barrier performance by their individual barrier performances, improving, for example, water vapor barrier or oxygen barrier. But it's also well known that such an approach would compromise the circularity, the recyclability of the material. In the Circular Monoplastic project, we use the process of atmospheric pressure plasma-enhanced chemical vapor deposition of silicon oxide barrier coatings on PET films. This approach allows us, first of all, to follow up the production capacity of other conversion processes like printing, sealing, etc. On the other hand, it solves the major challenge of the project to achieve the necessary barrier performance without compromising the monomateriality of the flexible packaging.
At home, when I'm standing with a plastic pouch or a sealing film, I dispose it as residual waste, and this is because I know it's probably not recyclable. Now, 60% of all our household plastic waste is packaging. Most of it food packaging and some of it flexible plastic films. We need to recycle all our plastic in order to make the society's plastic consumption sustainable, and it includes the flexible plastic films. This is what the project is all about. We want to create a PET film which is recyclable, and even more, it's circular. That means we are capable of recycling a flexible plastic packaging film into a new flexible plastic packaging film. Today's PET recycling facilities actually produces 99.9% pure PET. Well, we have reduced the amount of non-PET material in the project to less than 5%, but it's clearly not enough. So we also use environmentally friendly water-based printing inks and sealing layers, which together with the coating can be washed away, leaving a clean PET by the end of the day. Hence the circular loop we imagine is, after use, the PET films are collected and sorted as PET, they are shredded, they are washed, and then they enter into the recycling facility where they are decontaminated from volatiles and remelted and then blown again to a new film. Sounds easy? It's not. Even the smallest impurity, even the smallest degradation of plastic properties makes it nearly impossible to make a new film. So in the project, we aim to demonstrate the full cycle, and we have already had one batch through a recycling loop and got it back from India, and we are planning more recycling loops. So as a conclusion, the project aims and has demonstrated a flexible plastic packaging film made of only one layer of PET material, which both has the correct barrier properties to package even demanding food products. It also has the ability to enter into a circular loop, becoming a new plastic packaging film. And finally, the food safety aspects has been tested